TCP is set here at the transport layer. So understand this, visualize this. This is example.com, right? Example.com, you're typing it on your URL, you're typing it somewhere here, like I did webwhiteboard.com. We type it as users on here. This is application layer 7 for us. And once this goes, first it has to do a DNS resolution. For that DNS resolution, it would have to go to particularly a presentation layer, session layer, and then here at the transport layer, it will form a DNS resolution with one of the servers, right? This would be a DNS server here. So DNS server, that time it's coming to the transport layer. It can form a TCP connection, UDP connection. Then once it forms a TCP UDP connection, in order to interact with this DNS server, it's using network layer. And how is it using that network layer? Via the data link layer or Ethernet. That is basically Wi-Fi, right? So you see how each and everything for your web browser, you think, okay, I've just typed it in my web browser, everything is happening magically. But the entire beauty of a particular network layer exactly happens somewhere when the IP addresses and everything, IP addresses, the Ethernet, all these connections, that's the beauty of the network layer. That's how all your connections are happening. You must be thinking that, or let's say at a point of time, you might have thought when you were young that, okay, I have a modem, internet modem. The internet modem is getting connected to this. Once the internet modem is connected, I have the internet access. But understand this, that modem is just an access point of the internet to you. It's not the entire information of the internet is not there. The entire information of the internet is saved across different servers. So this is what happens. Now, let's say, I'll give you an example. Okay, now you typed your favorite website and something is not showing up. No page is showing up. What would you do?
Check for internet connection.
Great. Physical connection. Very good. Abhineet. What else could you check? Now you are cybersecurity students. You have studied computer networks, right? Now, which layer would you start troubleshooting based on the information you have?
Starting from the physical layer, data
Great.
link layer,
hmm
and next the application layer.
Why wouldn't you go to the network layer? You would look at the IP address also, right?
Yes,
Application.
whether it is DHCP or whether the IP is configured manually.
Correct. So yes. Now you're getting into the gist of the entire subject. I don't want you to think of this computer networks as a subject where you're only going to look at the application layer, but you're going to look at it from particularly at a point where, just a second, guys, 1 second. Hey guys, sorry about that. Just the work from home gets you into things. Great. So where was I? As students, you don't need to look at everything at an application layer or just the wire connection. I want you to look at it from a layers perspective. From now on, whenever I ask you, or whenever someone asks you, let's say I'm not being able to connect to the internet, or I'm loading my website, my internet connection is working and my website is not loading. That means it's either a connection issue at the transport layer or it could be an IP issue, right? Now, let's look at a simple example of OSI layers. What exactly, if I have to tell you, how would you learn the OSI layers? Anyone has a simple, uh, or this is how I learned OSI layers? It's simple. What you're going to see is all people seem to need data processing. I've typed it on chat. All right. So what does it tell? The first layer is application layer. Now, if application layer is there, what kind of protocols can be used in application layer? Can someone quickly tell me? In application layer, what do you see when you type a URL? When I type web.whiteboard.com here, what is there in front of web.whiteboard.com as well?
HTTP.
Great. HTTP is one of the protocols. If you're uploading, downloading files, it's FTP, right? And DNS. So these are three protocols where you're interacting with the applications. FTP, HTTP, and DNS. These become layer 7 protocols. Understood? Guys, any doubts still here?
Yes.
All right. Next come presentation layer. What exactly happens in a presentation layer? Here, whatever data we are sending from the application layer, right? It's either encrypted, compressed, all your SSL and TLS handshake. SSL is nothing but, can someone tell me the full form of SSL?
Secure socket layer.
Yes, secure socket layer. All this happens here at the presentation layer. Then we come to the session layer. What happens at the session layer? Let's say I'm conversing with you right now over Google Meet. How are we able to converse so properly and so easily is just because that I have maintained, or my connection, internet connection has maintained a session with the Google server that I'm able to communicate with you very fluently and easily, right? This is what happens at the session layer. It maintains the communication between sessions, all right? What kind of protocols can you use here? NetBIOS or PPTP. All right, point to point. Any doubts still session layer? See, it's theory. That's why I didn't come to college and taught you this. So practically, you need to be with me because in the next session, we are going to do labs from next session onwards. So understand the session layer. If I ask you anything, you look at what kind of, why I'm saying you remember the protocols because your labs, what you're going to do hands on, I'm going to ask you to search for certain terms and you need to know which layer to search it at. All right. So once session layer is done, we look at transport layer. Transport layer is the fourth layer. In transport layer, what exactly is transport layer doing is reliable delivery. It takes the port numbers. It also takes error detection. So what kind of protocols come here? TCP, UDP. Uh, Out of TCP and UDP, which is unreliable?
UDP.
DP.
Great. All right. Next, network layer is where the entire logical addressing happens. Or one of you said it was routing also. Yes, routing as well takes care of this. So here you use something called IP and ICMP. IP is nothing but what? Internet protocol. ICMP is what? Anyone ICMP? Internet Control Message Protocol. All right. Why do we use ICMP is in order to check if our connection is alive, whether that route is perfect or not. So do you guys do Cisco Tracer Packet Hub labs in your classes or in your labs? Guys, Do you have Cisco Packet Tracer as a lab? Okay, great. Then probably I'll show you one day how these things work. All right. Then after the network layer comes the data link layer. Data link layer, like we know, it's for physical addressing. Now understand this. What data link layer is doing, let's say Abhineet and I are talking. Abhineet sends me a message. I send Abhineet a message to the internet. It's going to use IP addresses of our ISPs, providers like Airtel, Geo, or what do we say, Tata. All these are going to know. But let's say when I am sending a message, how is the internet knowing that I have to send it to Abhineet? Or I have to send it to Abhineet's address and to this particular device. So that particular thing is done by physical addressing under data link layer, where it looks at your MAC address. Every device on the internet or every handheld or every device end device which is connected on the internet has a MAC address and it is unique to it. How does the MAC address happen is when the router receives, there's something called ARP, address resource protocol. All right. That address resource protocol converts the IP address to MAC address or maps the IP address to MAC address. That's what is happening at the data link layer. Physical layer, it's bits over cables or wireless. All right. So we have understood particularly protocols, or we have understood the OSI layers. I've taken you through it. Now, if you have to remember, like I said on chat, I've put if you want to remember it for your interview perspective or any time, right? Just remember this sentence: all people seem to need data processing. All is application, presentation, session, transport. Need becomes network. Data is data, physical data link layer, and processing is nothing but what? Physical layer, right?
Yes, sir.
Now, can you tell me if I have to ask you which layer do you think would uh, take care of the Wi-Fi connectivity? Which layer?
Data link layer.
Yes. No, why data link layer? Why do you think it's data link layer? I told you, right? Data link layer is only converting your IP address to MAC address.
Physical and data link.
Physical. It would just be physical.
Okay.
Understand this. You're looking at a Wi-Fi connectivity, right? You're not looking what's happening at the address. You're just looking at the connection. So at that point, the function of the layer is going to be at the physical layer. We are just checking the connection. Okay, this is an activity for everyone. What I want to do, you are about 27 of you are here. What I want you to do is, can you break when you're writing an email? What happens at each layer? I want you to do that and put it up on chat. Take 5 minutes of your time. All right. It's 11:26. At 11:31, you put up your answers. Write the breakdown. What exactly happens at each layer? You just write at application layer, transport layer, session layer. What all happens when you're writing an email? Take 5 minutes of your time. I just want you to write what exactly happens when you're writing an email. I am here itself. If you have any doubts, you can just unmute yourselves and ask me. All right. Can you start putting in your answers? Okay, I see no one has put up their answers. You can put it up in the chat if you haven't, or you can just unmute yourself and tell me. Okay, I see no participation, but that's fine. Well, if you're writing an email, right, at the application layer, what exactly happens is you write the message, then at the transport, great, Abhinit has sent. Application uses POP3, data encryption, great, conceals, connection gets established, uses TCP for delivery, adds IP address source. Okay. Uh, Abhinit, why didn't we use UDP? Can you tell me about that? Why did you particularly select TCP? You're speaking on mute. Okay,
Oh, I'm
UDP.
sorry. Yeah. So, yeah, TCP uses a three-way handshake where the message that is being sent is acknowledged by the receiver to the sender back so that the delivery of the message is confirmed. Whereas in UDP, it's a one-way traffic where the packet sent does not get acknowledged. So that's
Superb.
the reason TCP is being chosen.
Superb, man. Very good. Very good. So I think Abhinit, you were the one who asked me last time to do IP subnetting, right?
Yeah, yeah.
Great. So we'll do IP subnetting. We'll do some numericals. All right. So let me just help you guys out. Give me a quick second. Let me just set up a few screens here. How many of you are you guys aware of IP subnetting?
No, sir.
No. Okay. So most of the time you've heard IP subnets like this particular subnet being /24 /32, right? How many times do you get confused?
Most of the times.
Most of the time. All right. Great. So let me just load up the textbook. It'll be easier to explain from that. Which particular textbook do you guys refer to for your computer networks? Thanks, Bhargavi. I just saw your message. Do you guys use any particular textbook which the college has prescribed? Else, I'll send Bhargavi a textbook called Data Communications. Okay, no textbook, own printed notes. All right. So I'll send you one of the textbooks. This is for Data Communication by Ferrazon. I yet use it. So even you guys can use this. It'll be better. Okay, so there are two types of addressing, particularly in data communications. Okay, one is called classful addressing, the other one is called classless addressing. Classful addressing, particularly where do you would see it is in what do we say? Give me a second. See, when you're talking about the internet IP address, right? It's called as address space. What address space means is particularly, yeah, this is what I want to show you guys. Okay, this what you see, right? When we write that IP address is equal to 192.168. Yes, this is the one. Verizon A for zone. Bhargavi. This is the same textbook I'm using here. All right. So when I talk about anyone, when you see on an okay, cool. But if you guys want to study computer networks, please use this textbook. It has everything in detail. All right. So when we are looking at an IP address, right? IP address or wherever it says, we say it's an address space. Particularly, address space tells the total number of unique addresses um, that can be formed using a given number of bits. Anything on the internet or anything when you write on computer networks is taken as bits. So let's say a protocol TCP uses 2 bits. What is going to be its address space? 2 to the power 2. That whatever is the bit size, it's going to be, let's denote bits as B. So whatever is the number of addresses, it's going to be 2 to the power of B. So let's say if UDP is using 4 bits, what's the total number of addresses UDP can use? 2 to the power 3. What is 2 to the power 3? 8. 8 addresses is what UDP can use. All right. How many? Now IPv4 is about 32 bits on the internet. This entire thing, right? When you look at the network layer, IPv4 has a header. It takes 32 bits. All right. Now 32 bits means that I have about 4 billion addresses that I can have in that entire space of IPv4. 4 billion addresses. Now understand this, in today's world, IPv4 is depleting. That's why we're using IPv6. So 4 billion addresses have been used. That's the amount of people on the internet or amount of tokens on the internet. All right. Now, because IPv4 is using 32 bits, all right, it's divided into four categories. Okay, it's divided into 4 groups, octets. So when I write particularly, what do we say? So when we write one, so let me get this. So when we write particularly, oops, 192.1. So when we write an IP address like this, right? This particular IPv4 address, it's divided into 4 groups. So this is particularly 4 groups. Now it will be easier. Yeah. You see, this particular address space, right? It is divided into 4 groups. These are called octets, 4 octets. So each of these group of 3 is using 88 bits. 8 plus 8 plus 8, 8 plus 8 is 32 bits. That's why your 32 bits address comes. Now, what exactly happens? All these bits, right now we are seeing legible numbers in decimals. In the internet, it's converted into binary notation. And then they are dotted by decimals. This is decimal notation. On the internet, it is binary notation. So this 192 will be converted into binary. Do you know how to convert it to binary? Do you guys use your scientific calculators? Else, what you're going to do is, I'm just going to keep dividing 192 by, so let's take a table. So let's divide 192 by 2. Okay. Once you keep dividing 192 by 2 until you get a reminder, let me just pull up. Give me a second. I'll just do it for everyone. It'll take some time today, but I'll finish IP subnetting. In the next class, I'll continue with the packet analysis. Okay. Would that be fine with you guys?
Yes, Sarthak.
All right. So let's take particularly. So let's take this. So the number, then particularly quotient and remainder. So we have 192, right? 192 divided by 2 would give you 86. 2 8s are 16. All right. It's 19, right? 8 2 9s is 18. So 9 and 6, 96. Reminder is 0 here, right? Then when I take 96, reminder is going to be 0 again. Quotient is what? 48. Forty-eight is going to be 24. Reminder 0. 24, 12, 0, 12, 6, 0. 6, 3, 0. 3, 1, 1. You guys are following me, right?
Yes.
That's it. So now for our 192, this is the binary. We go bottom to top. 1, 1, 0, 0, 0, 0, 0. So this is 8 bits. Got it? How that 8 bits is given? So when it's converted to binary, you have 8 bits. So this is how numbers are converted. I hope you understand, or I hope you got how the binary calculation can be done. If you're using a scientific calculators, you can easily do it. But if you're doing it via paper, you just keep dividing it by 2, whatever the reminder is there. Write it from bottom to top. You have to divide it 8 times by 2. Okay, cool. So coming back to this, particularly, there are 4 classes of addresses. Okay, classful addressing, what we call classful addressing is there is something called prefix length and suffix length in IPv4 addressing. So if the prefix is defined already, right? If a prefix is defined already, it has a constant length which is defined. That's called classful addressing. Now there are 5 classes, A, B, C, D. For a class A, N is about the prefix length is 8 bits. Okay, 8 bits of prefix length. So their suffix length is 24 bits. 32 minus 8, 24. And so if you have to calculate the number of addresses, how many number of addresses it's going to be? 2 to the power 8, which is how much? 128 addresses. Okay. So a class A, if someone tells you this is a class A address, it is given by /8. Understand it? It's a class A address /8. You got that concept when I write something like (10.0.0.0/8). Which address does it belong to? Which class of address it belongs to?
Class A.
Class A. When I say slash particularly 16 or /10,
Class B.
let's say class B. How many addresses it's going to have? Two to the power 16. 32 minus 16? 16, right? So whatever is the prefix length, you do 2 to the power n. N is nothing but the prefix length. Okay. This. When I say /24, it's a class C address. So it uses 24 bits of space. So you have about 2 million packets. In class B, you have 16,000 addresses. Class A, you have 128 addresses. Understand this. The class A address, right, what you're seeing would start from 0 to 127. It would end at 127. So if I say 10.0.0.0 is the first address, the last address for that class A is 10.0.0.0.127. What's the prefix length? It's a prefix is given here. How would you identify what's the prefix length? /24. Don't do anything. Just look at the IP address. Your prefix /24 is which class of address? Class C. Look at the table. Class C. So what I'm making you guys do is understand when someone gives you an IP address, right? I don't want you to think as students. I just want you to think as logical people. I've given you IP address. How you're going to find the information out of that IP address? This is the IP address. What is going to be the suffix length for this? 32 minus 24, 8. That will give you the suffix length. Now, if I have to tell you to find the first address of this, how are you going to find it out? You convert this 192.168.1 into particularly a binary. Okay, so let's do this slash notation. Take this. This is the example I've given you. Okay. What I want you to do is, if I give you anything has an IP address, you need to find out, you need to start extracting the information. That's going to be your task. Whenever someone gives you an IP address, they expect you to do it on your own. All right, they're not going to tell it belongs to class B. So once I give you an IP address, let's say I've given you an IP address 192.168.1.0/24 in your chat. First thing is you can find the number of addresses in this. How you're going to do that? You know that it's ending with /24. Okay. Yeah, you're going to use the first formula here. Number of addresses that can be found in this block is 2 to the power 32 minus n. So 2 to the power 8. That means 16,000, around 16,000 addresses you're going to have. Then how can you find the first address and the last address of this particular uh, subnet? So see here, let's take this example. You guys have a pen and paper with you?
Yes, yes.
All right. Let's take this example 167.199.170.82. Find, can you, now you need to start extracting information from this address. I know that it has about /27. That means its prefix length is 27. It's going to take the first 27 bits in that 32 bits. So in that first 32 bits, what I showed you particularly here, right? These are 32 bits. In these 32 bits, the first 27 bits are all ones, or all ones, because these are preserved. That's what it means. Are you guys clear with me still here? What that 27 bits indicate? Any doubts still there? Guys, you need to be interactive, otherwise I'll keep just speaking. Or do you want me to explain this again?
I couldn't
No,
follow
sir.
that particular thing. Can you just, yeah, come over again if you don't mind?
All right, sure. So let's say when I say in that example, right? Let me just put that thing on the chat. Give me a second. So we know from this particular IP address /27 indicates that in an octet, in a 32, in an IPv4 octet, the first 27 bits are 1 dot 1 dot. So this becomes 1, 2, 3, 4, 5, 6, 7, 1. Four, 5, 6, 7, 8. Yep. So particularly this particular 167.199.170.82/27 tells us this. That means this much length, prefix length, is already taken by the first 27 bits. The /27 indicates that these first 27 bits in that IPv4 address has been taken by the subnet or that network ID. The prefix tells us the network ID. Remember this, I forgot to mention this. The prefix always tells us the network ID. The suffix part, that is the ending part, tells us what exactly is the host. Now, are you getting the point?
Yeah.
Okay. Prefix, understand this. It's a reserved ID. It's a reserved set of numbers. So this particular, in this address, still here, it is reserved. That means 167.199.170 cannot change at all. Anything that has to change will change in the last octet. Understood? That 167.199.170 becomes a network ID for that address. I think I made it more simpler for you now.
Yeah, but I couldn't get how this fixed length of octet just got converted to simple 111s.
Oh, that's an example I'm showing you. I'm just
Oh,
an example. It's
okay.
just saying that the first 27 bits in this particular IPv4 address I've not converted 167 to binary yet. Okay, we're going to convert it in the next step. I'm going to teach you that.
Just
So
to represent that it is occupied, you have taken it as 111.
1111111. That's
Ah,
how it is taken in the network layer. All right.
okay.
Next, what happens is now, in order to find the first address, what we are going to do is we are going to take the first five here. 32 minus 27 is 5. So the number of addresses we are going to have is 2 to the power 5. That is 32 addresses. In this address space, how many addresses can you have? 32 minus the subnet, that is 27. Will give you 32 addresses is what this particular network ID can have. Now, using this, what we can find the first address and the last address. So what we're going to do is simple. We convert particularly this 167.199.170.82 to binary. Can someone quickly give me the binary for this? Or I can pull up, I can do 167 with you guys. Until then, can someone do, wait, I'll put the IP address on the chat. I need few of you to convert it. Or if you're using a calculator, convert 167.199.170.82 to binary. So let's convert 167. So 23 would give me 1 as the reminder. Here it's going to be 1 and 11. 1 as the reminder. 5 and 1. 5 and 2. 1, 0. So my octet is going to be what? 10111. Let's see if I'm correct. What did I do wrong? I had a disconnect on the internet. Really sorry about that. Did you guys convert it to binary?
Yes, I guess Bhargavi has also posted the conversion.
Oh, 1 second. I did it wrong. I made a mistake. Silly error here. It should be 83. So it's going to be 1. Sorry about this. So 83 and it's going to be 41 here. 41 would give us 1 as the reminder. 41 divided by 2 is going to be 20 and 1. 20 is going to be 10. 0, 10, 5, 5, 2, 2, 1, 0. 1 divided by 2 is going to be 0. So 1, 0, 1, 1. All right, let me just see the chart as well. Okay, cool. So once you have divided into binary all these particular octets, you'll get 1011, 1011. Particularly, this is the values you should get. What are you going to do for the first address? What we're going to do is whatever is the last five numbers. How did we get the five numbers? We subtracted the value right here. This n, we found the value of n, the number of addresses in the block, or the number of address in this block is going to be 32 minus n. So that 5 bits, look at this. We're going to keep the n leftmost bits. We are going to keep the n leftmost bits, and we're going to set the rightmost bits all to zeros. For the first address, all these according to the solution, how they find it, or according to the process, we set the last 5 digits, the 5. Why we are getting 5? The number of remaining, like I said, the first 27 bits are reserved. Only the last 5 bits are that can change. The host can change. So these last 5 bits here will change to zeros. And for the last address, it will change to ones. This is how you calculate the first address, last address. And this is how you get to know that, hey, this is the particular subnet. Now you guys have you have an idea how what we tell about subnetting?
Yeah, somewhat.
Any doubts? Any doubts? I'll stop sharing my screen. You can ask me your doubts. I won't go beyond this right now. Tell me, what are your doubts? Abhineet, what didn't you understand out of this?
Um, Maybe I was trying to visualize how it works in the reality. Theoretically, yeah, somewhat there is a fair idea. So,
So reality also it works like this. When I say a /24, right? So what
okay.
happens is there's a industry called ICANN, all right, the internet industry, ICANN, all right. These guys give a block of addresses. They give the /16 or /16 subnet to each and every companies. Okay. Now, as a college RNSIT, you guys would have a /16 subnet, which is then divided into smaller blocks of /8, /24. So let's say your different department. Let's take RNSIT has one university, right? Under RNSIT, we have different departments. Department for CSC, Department of Cybersecurity, Department of EC, right? So let's say I get one subnet there saying that this is our subnet called /16 subnet because /16 subnet has the maximum number of addresses. How many? We'll have about 4 million addresses because we know /16 will be 2 to the power 16. Those are the number of addresses. Or let me make it simpler. Okay, Abhineet, if I have to give 100 addresses to an organization, which class of address would you give it to them? The Go ahead.
Class C.
Why class C? I just want 100 addresses.
You mean to say 100 IP addresses?
100 IP addresses, yes. Which class of everyone else can also answer if anyone knows the answer. In reality, what exactly happen is, as an organization, when I go to the internet or when I go to the particular ICANN, I have to tell that I need these many IP addresses. All right. According to that number of IP addresses, ICANN gives me particularly a class of addresses. Let's say, like I said, Abhineet right now, I want 100 addresses But Abhini told that you can take class C addresses. Class C is about 24 bits of addresses. Okay, 24 bits, meaning 2 to the power 24 minus 32 is going to be 8. So 2 to the power 8 is how much?
128.
Yes, great. Sorry, I did the calculation wrong. Correct. So yes. So to the Abhineet was right. He gave me 128 addresses based on my needs. But now understand, if a company says that I want 10,000 addresses, which particular class of address would you give them?
Class A.
Class A, right? But I just wanted 10,000. And class A has how many addresses?
About 4 billion.
Yes. So 10,004 billion. How many addresses are we wasting?
About 3.9.
3.9
Yeah.
billion addresses we have wasted. So
Yeah.
this is what is happening in the reality. That's why they're breaking those particular networks of slash this class A into smaller networks also. That's why your subnetting comes into picture. So I'm going to say in class A, so let's say class A is slash 8, right? In that slash 8, if I'm saying that, so what can happen is I'll start changing the network IDs. I'll say 10.1.0 dot slash 24. So what will happen is, though this network ID belongs to this subnet, it's a part of this class A subnet itself. I've broken it down into a smaller subnet so that I can lend it to someone else as well. Same way, all both of these slash 24 would belong to slash 8, because slash 8 is a class A subnet, slash 24 is a class C subnet. So these are the networks where I see where you guys are getting confused. How is this happening? Is simple. Like I said, I had a ask for 10,000 addresses, right? But I was given a class A address that is about 4 billion addresses. I don't want to waste so many addresses. So that's where I start subnetting it. This is in reality how subnetting happens. I hope I have answered your query to some extent.
Yeah, it feels more simple and clear now. Yeah.
Yes, great. So this is how subnetting works. Now, if someone asks you, can you give me the network information from the slash 24? Will you guys be able to do it?
Yeah.
All right. So that's it. So next class I'll do packet analysis. All right. I'll schedule it with Bhargavi. I hope I made your Saturday little fruitful. All right, guys. Thank you. Have a lovely evening, a lovely afternoon as well.
Thank you, sir. Thanks a lot for the informative session.
Thanks, Sarthak.